Hello, everyone. In today's lecture, we are going to discuss a discrete time Markov chain case study to model the credit card company and how they monitor the payment process. So this is the outline of today's lecture. First, we are going to have a look at the problem. How to the tracking of the payment process. Then we're going to talk about how to use the DTMC to model the payment process. And based on the DTMC model, we're going to analyze different policy to terminate the account. And also policy may have different performance if we add the data collection. So that's one more thing we are going to analyze different kind of policy. So let's first have a look at the problem statement. We all know that credit card company track the payment history of accounts. Okay, if an account holder fails to make the minimum payment, we call this delinquency. Okay, so state K actually represents missing the minimum payment for the last K consecutive month. So here we use XN to denote the state of a customer account at time N or the nth month. So the state space is from 0, 1, 2, 3 until 6. And a customer in state K has 4 possible futures. Make a minimum payment. Then they're going to move back to stage 0. Okay, that means they don't miss any minimum payment if they make a minimum payment or more. If they make no payment at a stage K or less than the minimum payment, it will move to stage K plus 1. So default by declaring bankruptcy, thus bankruptcy also moves this account to stage 0. The company can cancel or terminate the customer's card and account, then moving to stage 0. So here the policy is, so this is one policy, terminate an account as soon as it misses the 7th minimum payment in a row. Okay, so and then write off the remaining outstanding balance on that account as a loss. So this is the current policy. We denote it as policy current. So because we terminated the account as soon as it misses the 7th minimum payment, so with the state space only includes from 0 to 6, because when it comes to 6 and make one more transition to 7, it's not going to reach 7, because if you miss the 7th, it will automatically become 0. So you just come back to 0. So this is only 0 to 6. That's why the state space from 0 to 6 based on the current policy. So the probability K as shown in this table, this is extracted from the historic data. Probability K is the probability that a customer in state K fails to make the minimum payment in the current period and then moves to state K plus 1. So for example, this one is 0.033. This is a probability to fail to make the minimum payment and then move to state 1. In state 1, he has already missed the 1 month's minimum payment. Then with the probability 0.048 to move to state 2. Okay. So QK is the probability that a customer in state K declares bankruptcy in the current period. That means in this state, you can declare, the account holder can declare bankruptcy. Then immediately, for example, in state 3, this 0.052, this probability, this account holder can declare bankruptcy, then automatically it will move to state 0 immediately. It will not move to state 4. So if the account is terminated, then BK is the average. This is the average outstanding balance of a customer in state K. So if we terminate the account as soon as it misses the 7th minimum payment in a row, then this balance will be gone. It will be marked as a loss. Now let's develop the DTMC model. So xn plus 1. Xn is the state of a customer at time n or the nth month. Okay. So xn can take the value like 2. So xn, the state is of the customer account is miss 2 consecutive months payment, minimum payment. Now xn plus 1, it will become xn plus 1. So this n plus 1 denotes, okay, in the next time point, okay, or the next month, it will become xn plus 1. That means from if the account holder missed 2, then it will become 3. So next time period, if the customer misses the minimum payment in the nth month. If the customer makes a minimum pay in the nth month or declare bankruptcy or the account is terminated, then xn plus 1 will become 0. Okay. So this is what we discussed. It will become 0. Bankruptcy will become 0. Okay. Make the minimum payment or more becomes 0. Bankruptcy becomes 0. Terminated account becomes 0. Okay. So 0 under these 3 conditions. Make the minimum pay, make the or more than minimum pay, or declare bankruptcy, or the account is terminated. So based on this state definition, we have the transition probability PK, K plus 1 equals to probability when xn equals to K, means the K consecutive months minimum payment. Then the next one will be K plus 1 consecutive months minimum payment. And this is a PK, okay, from state K to K plus 1. And for this one, K actually less than or equal to 5, greater than or equal to 0. But when K goes to 6, okay, when it goes to 6, it will not make the it will not go to 7. It will automatically go to 0. So this will become K0. But in any state, in any of this state, you have a probability to go to 0. That is, declare bankruptcy or terminate the account or make the minimum payment. But this is from any state K to 0. This is actually 1 minus PK. PK is miss the minimum payment. You go to the next stage. If you don't miss the, if you make the minimum pay or declare bankruptcy or account is terminated, so this is actually 1 minus PK. So the probability to do all these 3 is actually 1 minus PK. This is PK. Okay. So let's see the 3 conditions. You see here, in state 0, there is a 0.033 to make the transition to 1, and then 1 minus P0, 0.0033, 1 minus PK, P0 is 0.967 to stay in 0. Okay. So if it is in state 1, then we have 0.048 to go to state 2, and then 0.952 to go to state 0. So this 0.952 includes 3 conditions: make the minimum pay, miss the pay, terminated, or declare bankruptcy. Same for all other states. You see, for state 3, there's a probability 0.165 to go to state 4, and there is also 0.835 to go to state 0. So this line actually includes 3 conditions. This is 1 minus P3. This is 835 is 1 minus 165. So this line actually includes this condition, makes the minimum pay, you go to 0. Because you have already made the pay, and automatically you don't miss any minimum payment. If you miss the pay, you make the minimum pay 0. If you miss the pay, got terminated, the account automatically go to 0. If you declare bankruptcy probability is stage 3 is 0.052. So there's 3 conditions you go this route. So that's why this probability is higher. Now this is a transition probability diagram. And you can see among all these states, what are the transitions. So this probability to go to 0, 1, 1 to 2, 3 to 4, 4 to 5, 5 to 6, and 6 can make transition to 7, but 7 automatically becomes 0. So there's no 7. So we have PK. PK is from K to K plus 1, and then 1 minus PK goes to 0. So hopefully at this point, we are clear about the transition probability and also the probability to go back to 0 under these 3 conditions. So here 3, make the minimum pay, bankruptcy, or terminate. Okay. Now, the current policy is to terminate an account as soon as missing the 7th payment, write off the remaining balance. So the loss in the case state K, so the expected annual loss from an account in state K in a month, okay? In a month. So if we have loss actually at average state, if it got terminated or bankrupt. So QK, what is QK? QK is the probability to declare bankruptcy. So if declare bankruptcy, then all the outstanding balance got written off. So this is for state K from 0 to 5. When it comes to the state 6, there's a probability that this account will get terminated. So the probability to terminate is probability 6, then we're going to write off the B6 balance. And also there's a probability that declare bankruptcy, then we're going to write off the balance. So these two add together is a loss at state K. State K equals to 6. But from state 0 to 5, we write off the balance only when the user declare bankruptcy, because we're not going to terminate account under the current policy when the customer account is state is from 0 to 5. Okay. Now, based on this equation, we can calculate, because we have all the QK values, we know the outstanding balance at each state. So we can calculate the loss for every state if it is in this state. And we also need to know the limiting distribution, that is a long run proportion of time to stay in a particular state. Okay, so we have balance equation and the sum equals to 1. So this is our P. Based on the P and the balance equation, we can calculate the pi, limiting distribution. Then in order to calculate the expected loss, okay, so we add all this pi k lk together from state 0 to 6. Then, because this is in a month, right? So we got 37.6417 per month, the loss. The annual loss under current policy, you multiply by 12 months, this is $451.7003. So this is our loss under current policy. Now, if we have, if there's a data collection agency, we can the company can use, then there is a different scenario. So if the customer declare bankruptcy, the company loses the entire outstanding balance as before. But if the customer does not declare bankruptcy, the company can decide to terminate the account and turn it over to the debt collection agency. So if decide to do this, the debt collection agency pays the company 75% immediately of the current outstanding balance on that account. When the account is turned over to the debt collection agency, it connects the outstanding balance on the account from the account holder by legal means. The credit company also has to pay DCA an annual retainer fee. That means you need to pay an annual fee to use this agency, like 50,000, okay, for this service. Now, policy options. Should we hire this DCA or not, the debt collection agency? And also, if we hire the DCA, when to turn over an account? That is when the customer missing how many minimum payment, then we terminate the account and turn it over to DCA. Now, let's suppose the policy M is turn over an account if miss M minimum payment. This M can be greater than or equals to 2 or less than or equal to 7. So under PM, XN DTMC with state 0, 1, 2, because if it is 6, then this is, if it is 7, this is 6. If it is 6, it is 5. If M equals to 5, this is 4. And now the cost is a little bit different. This is still the same. If the customer declare bankruptcy, you lost the entire balance, right? Entire outstanding balance. But if the customer does not declare bankruptcy, and if you turn the account to the DCA, then what are you are going to get 75%, okay, of the outstanding balance. What you lost is only 25% of what before, okay. So still make the transition, but you are not going to terminate, but instead you turn it over to DCA. But in state K, the customer can still declare bankruptcy. So there's a probability that he missed the payment. Then you turn it over, or declare bankruptcy and then you lost the entire balance. So this is only change here, 25%. You're going to lose only 25% before if they miss the case payment here, minimum payment, K consecutive months payment, and then the entire balance. This is because the DCA pays 75%. Now, let's have a look at the policy of P2. That means turnover account if the customer misses 2 minimum payment in a row. So XN, n greater than or equals to 0, DTMC with state space 0 and 1. So the transition matrix you see here, so 0.033, and then this is right here, 0.033. So you only keep these two values and these two values. You only have two states, 0 and 1. And then you go from 1 to 0. Okay. So this is 967.033 and 10. You only keep these two values, 2 by 2 matrix, because you only have two states. So we can continue to calculate the limiting distribution and the loss in a month. So this is a loss. Okay. Now, the expected loss is this is loss in a particular state. Now, expected loss is pi L0 plus pi 1 L1. So this is 38.3250 per month. Then multiply by 12, we got the loss is under P2, and also with the data collection agency. This is the annual loss will be 459,9005. This is actually more than what we have in the current policy without using the DCA. Okay, that is the 7th consecutive months. Then we terminate the account, but we just all the outstanding balance goes away. We don't use DCA. And P2 is much worse. Now we can continue to compute P3. This is 452. P4, that means turnover account with 4 minimum payments in a row. You see, this is getting smaller. P5, now when it comes to the P5, we have the DCA. This is smaller than current policy. And the smallest one is P6. So P6 means turnover account if miss 6 minimum payment in a row. Okay, turn over the account and and give it to DCA. And P7, this is with DCA. This is also 451.6828. You see, this one is also smaller. With DCA, obviously, the loss is smaller. And P6 is the minimum. So suppose we're going to use the DCA and employ this policy. The saving for one account is actually 0.0194 per month. Okay, not per year. Now, annual fee is, we talk about if we want to use DCA, the annual fee is 50,000. So how many accounts we should turn them over to reach a balance that is 50,000 divided by this saving? Then we have to turn over 2,577,319 accounts to DCA to reach an even. But if we have 14 million accounts, then the saving will be like minus 50,000 will be 221,600 savings per year. So this is a cost analysis under for different policy with the DCA, and also this PC is the policy without DCA, without data connecting agency. So those P2, 3, 4, 5, 6, 7, they are with DCA. Okay, so this is end of this DTMC modeling for the credit card company. And as you can see, how we can use the DTMC model to analyze the cost and also the cost benefit for different kind of policy, and when to terminate an account, and whether to use the data connection agency. And if we use the data connection agency, turnover account, when the user or customer miss how many payments, then we turn over the account. Those kind of questions can all be answered by discrete-time Markov chain models. And in order to get those, for example, those transition probability, we need to connect historical data to analyze how many accounts they actually make those transitions, and what's the probability in each state this transition is going to happen, and also what's the probability to declare bankruptcy, and also average outstanding balance in a particular state. So those needs to be extracted from the data. But you can see how DTMC is applied in this case study. Okay, in the next lecture, we're going to talk about CTMC model. Okay, see you in the next lecture.